In this section, let's examine the different types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. The most common type of learning in the applied space is supervised learning. In a supervised learning algorithm, computer code that looks for patterns in data seek to build a model that can make predictions. These algorithms are often referred to as models. Supervised learning is a type of machine learning that enables the model to predict future outcomes after the model has been trained and tested on past data. The end goal of the model is to be able to make predictions based on data the model has never seen. In supervised machine learning, that data has been labeled. The label, often referred to as the target variable, is that entity we're trying to predict. The second type of learning is unsupervised learning. In unsupervised learning, the model is not given a data set which is neither labeled nor classified. The model explores the data and draws inferences from the data to define structures from that unlabeled data. Unsupervised learning is a more complicated process. The third type of learning is called reinforcement learning. Reinforcement learning is training by rewards and punishments. Unlike supervised and unsupervised learning, the model learns from bad experiences and then adjusts itself according to the environment or task it's been assigned to. Reinforcement algorithms are not given explicit goals. Instead, they are forced to learn the goals by trial and error. In reinforcement learning, the agent observes the environment, takes an action to interact with the environment, and receives a positive or negative reward. The agent is the entity involved in the learning process. An agent takes actions, for example, a drone making a delivery or a computer game character navigating a video. The algorithm is the agent. In life, the agent is you. Most have applied machine learning to supervised learning. In supervised machine learning, you'll often build two core classes of models. They are classification and regression models. Classification is used to categorize different objects. For example, when assigning an image as a picture of either a cat or a dog. In a classification problem that has only two choices, the problem is known as a binomial classification problem. For example, our model that places spam into two disparate bins is a binary classification model. The output from the model is a 1 for spam or a 0 for not spam. Many problems in the applied space will use binary classification. When there are more categories, the problem is known as a multi-class classification problem. In a regression problem, the aim is to predict the output of a continuous value, like price or probability. The attribute x is the input variable, and y is the output variable that we are trying to predict. In our example, the x and y look somewhat linear. That means you could draw a line somewhere on the graph that would describe the relationship to the various data points. When there is a single input attribute x, and you want to use linear regression, this is called simple linear regression. When there are multiple inputs, this is called multiple linear regression. One of the most popular approaches to unsupervised learning is clustering. Clustering deals with finding a structure in a collection of unlabeled data. Given a set of data points, you can use a clustering algorithm to classify each data point into a specific group. Ideally, the data points in the same group should have similar properties, while data points in different groups should have different properties. A cluster is therefore a collection of objects which are similar between them and are not like the objects belonging to the other clusters.